Welcome to Fractal Frontier Maths, your space for mastering national level exam problems and higher mathematics. I'm your guide for today's deep dive solution. If you are preparing for exams like CSIR NET, GATE, or seeking to strengthen your fundamentals in mathematics, you are in the right place. In today's video, we will tackle a classic problem from the CSIR NET June 2011 mathematical science paper. Our approach will be step by step, which is perfect for both the beginners and advanced learners. Don't forget to join the channel community for more solutions, tips, and exam strategies. The link is in the description. The problem is to check if the given initial value problem exists and is unique. That is, we need to check existence and uniqueness of the given initial value problem. To proceed the given problem, we will use Picard-Lindelof theorem, which is also called existence and uniqueness theorem. The theorem states that if a function fxy, which is defined on a domain D of R cross R, is continuous with respect to variable x and Lipschitz continuous with respect to the variable y, then the initial value problem dy by dx equal to f of xy subject to the condition yx0 equal to y0 has a unique solution in an interval containing 0. We will recall some facts before approaching to the problem at hand. A polynomial function is everywhere continuous and differentiable. Another fact is a function fxy defined on a bounded domain D is called Lipschitz continuous function with respect to the variable y if the first order partial derivative of f with respect to y is continuous function on domain D. Now the given initial value problem is u dash t is equal to p u of t subject to the condition u0 is equal to 1. So we have then p is a polynomial function of degree n which is greater than equal to 2. Okay, here f of t comma u is equal to p of u. Okay, so since p is a polynomial of degree n, p of u is a polynomial and every polynomial is continuous, so p of u is a continuous and differentiable function. Now del f upon del u, which will be p dash u. So p dash is also a polynomial and it is a polynomial, so p dash u is continuous. So both thus f t comma u is continuous with respect to variable t and its derivative, partial derivative with respect to u is also continuous. By Picard-Lindelof theorem, the initial value problem u dash t is equal to p of u subject to the condition u01 has a unique solution in an interval containing 0. Okay, so the option 4 is the correct option. We can also attempt this problem by eliminating option which are not correct. The problem states that P is a polynomial of degree n which is greater than equal to 2. So we can take polynomial as P of u is equal to u square, which is a polynomial of degree exactly 2. The given initial value problem reduces to du by dt is equal to u square subject to the initial condition u0 is equal to 1. Let's solve this problem. So by separation of variables, we can separate each the variable, that is u and t. We will get du by u square equal to dt. Now integrating both the sides, okay, the integration of 1 upon u square will be minus 1 by u, and integration of t will be t plus a constant, let's say a. The given condition is u0 is equal to 1. Okay, therefore by substituting the value of t is 0 and u is equal to 1, we will get minus 1 equal to 0 plus a. So a will be minus 1. We will plug this a in this equation. Therefore minus 1 upon u is equal to t minus 1. So by rearranging the term, 1 upon u is equal to 1 minus t. Therefore the solution of the equation will be ut is equal to 1 upon 1 minus t. So this is the solution when the function is u squared. Okay, so we can see that this factor will be 0 when t is equal to 1. So solution exists only when t is not equal to 1. Therefore solution exists when t is not equal to 1. Okay, so we have calculated the solution ut is equal to 1 minus t, which is unique solution. Okay, and it exists when t is not 1. So first option, a unique solution is incorrect, because solution does not exist when t is equal to 1. N number of distinct solution? No, there is only one solution. No solution in any interval containing 0. There is indeed a solution which is ut equal to 1 upon 1 minus t. So there exists solution, so 3 will not be an option. Hence option 4 is correct. Okay, and the proof that option 4 is correct we have provided earlier. So much for watching this video and for spending your valuable time learning with me. If you found the solution helpful or learned something new, please don't forget to give it a thumbs up. Your likes, comments and shares help this channel reach more passionate learners like you. If you haven't already, hit the subscribe button and ring the notification bell so you don't miss any future videos on advanced mathematics and smart problem solving strategies. For further discussion, resources and community support, join our Telegram channel which is in the description box. Thanks again, keep practicing and exploring math, and I'll see you in the next video.